binary number system, or you call it number basis. Number basis. Okay. Now, what are number bases? If I write 0, 1, 0, 1, 2, 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, till you get to 9. Now, how many numbers do you have here? 2. How many numbers do you have here? 3, 4, 6, and 10. Now, because of this, if you're working with numbers, just 0 and 1, you say this is a base 2 number. This is the one you call binary. And this is base 3 number. This is base 4. This is base 5. No, base 6. And this is base 10. And also, base 10 numbers are called decimal numbers. Okay. So it depends on the number you are working with. If you're working in base 2, the only numbers that will be featured will be 0 and 1. If you're working in base 10, you're going to have from the numbers 0 to 9. Let's quickly look at conversion of numbers. Conversion from base 10 to binary. Okay. From base 10 to binary. Now, what are base 10 numbers? I could just give you this. If I say 20 without putting anything, it is a base 10 number. I may decide to write the 10. So this is pronounced as 20 base 10, or 20 to the base of 10. I want to convert this to a binary number. I'm going to use the division method. How do you convert 20? So you draw 2 columns, and on the second column, you write 20. What is the number you are converting to? The base. The base is binary, which is base 2. Now, you are going to be using 2 to divide. 2, how many times will 2 go in 20? That is 10. Remember, there is a remainder, which is 0, because there's no remainder actually. 2 go in 10, that is 5. What's the remainder? 0. How many times will 2 go in 5? That will be 2 times. Now, this time around, there's going to be a remainder, which is 1. How many times will 2 go in 2? That is 1 time. And this time around, there will be no remainder. And finally, can 2 go in 1? Absolutely. You write 0, and then you bring down the 1. Now, writing the numbers, starting from the last one to the first one, you will have 1, 0, 1, 0, 0. This is the number in base 2. So this is the binary number of this number, 20 base 10. Now, you can actually do vice versa. You can do it vice versa. Suppose I ask you to rewrite. I want you, maybe this is a fresh question now. So I ask you to convert 10100 is 2 to base 10 number. So what will this be? If you're converting to base 10, this is the technique you're going to use. So listen very carefully. You write 1, 0, 1, 0, 0, and on top of it, call this 0, 1, 2, 3, 4. Once you're able to do that, remember, the base of this number is 2. So you're going to be using the index system to do that. Let's go back. 1 times 2 raised to the power of 4 plus 0 times 2 raised to the power of 3 plus 1 times 2 raised to the power of 2 plus 0 times 2 raised to the power of 1 plus 0 times 2 raised to the power of 0. In any case, anywhere you see 0 times a number, of course you should know this is going to be 0, this is going to be 0, and this is going to be 0. So what you have to do right now is to pick this. 1 times 2 raised to the power of 4 plus 1 times 2 raised to the power of 2 plus, I think that's all, plus, you could just say plus 0. Now this is 2 to the power of 4 means 2 multiplied by itself 4 times. That will be 2 times 2 times 2 times 2 plus 2 to the power of 2, 2 times 2. This is therefore equal to 16 plus 4. And what is 16 plus 4? That is 20. As you can see, there is a connection. And what is that connection? I have been able to convert this number back to a base 10 number, which is this, 20. Why don't you try this and see? Question 1. You may pause the video and try and see if you can do it. It says, write the following binary numbers as decimal numbers. I'm going to allow you to do question A. Try and see if you can do it, and then you come back to the video. Now let's get back to business. 11 is a binary number, meaning that the base is 2. You want to write as a decimal number. So to base 10. So let's follow the same process. You have 1, 1. Remember, it's in base 2. And on top of it, you number 0, 1. So this will be 1 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 0. One thing you must know is any number raised to the power of 0 is always equal to 1. So this is 1 times 2 plus 1 times 2 raised to the power 0, which is 1. Therefore, 2 times 1 is 2 plus 1 times 1 is 1. And finally, your answer is 3. If you choose to write 3 and write 10, it's the same as just leaving your answer as 3. If you write 3 without anything below, it means that it's a number that is in base 10. Now, why don't you go to the second question that says, you should write the following decimal number as a binary number. So, question A there says 4. Remember, since it's a decimal number, it's in base 10. So you write it down like a subscript. How do we go about this? Remember, you draw a 2-column table. You have 4 on the side, and the number you are converting to is binary, which is base 2. So you're going to use 2 to divide 2 and 4. That is 2, remainder 1. 2 and 2, that is 1, remainder what? 0. Oh, sorry, I beg your pardon. I just made a mistake here. So 2 in 4 is 2. There is no remainder, which is 0. And then 2 in 2, 1. And also, there's no remainder, but 2 in 1, that's impossible. So you write down 0 and you bring down the 1. So this is it. Now, what is your answer? It means 4 in base 10. So a binary number is 1. Remember, you're going to take from down to up. 0, 0, base 2. This is the answer. So do well to check the other videos for addition or subtraction of binary numbers, as you're going to be learning on how to subtract, add numbers in their different bases. Okay, I'll see you next time. Bye for now.